Today, I want to remind something profound to all my viewers. A tree doesn't worry about where its next leaf will grow. A river doesn't question where it will flow. Yet, we, with all our intelligence, learn in fear. The beauty of learning is in trust. When you trust, you flow. When you flow, you are free. From today, trust that what must come will come and what must go will go. And what is meant for you will never miss you, and what is not meant for you, no matter how tightly you hold, will slip away. The more you try to control learning, the more you suffer. Suddenly, if you trust, learning becomes effortless. See here, today's topic is on group theory, and this is the most important theorem. The theorem statement states that in a group G dot, for A comma B belongs to G, the equations Ax is equal to B and Ya is equal to B have unique solutions in G. So, what is given? See here, it is given that G is a group. Given that G is a group, and it is also given that A comma B belongs to, see here, A comma B belongs to the group G. So if you see, G is a group means it satisfies how many properties? Closure, associativity, identity and inverse. Now I am taking the inverse property. See here, for A belongs to G, for A belongs to G, there exists A inverse belongs to G such that, as you all know, that is A into A inverse is equal to identity element, which is equal to A inverse into A. This is the fourth property according to G dot is a group. As G is a group, it satisfies closure, associativity, identity and inverse. According to our fourth property, I am taking the inverse element. For A inverse will be the element and which is equal to identity element. Now here in the group G, A and B belongs to G and the equations Ax is equal to B and Ya equal to B have unique solutions. Now I am taking the first equation. See here, consider the equation. Now consider the equation. Consider the equation Ax is equal to B. And now we have to find the solution. What will be the solution? X will be the solution. Now from both sides, I am multiplying with A inverse. A inverse into Ax is equal to A inverse into B. As you know that, so it satisfies associative law. So this is A inverse into A into X is equal to A inverse into B. So according to our A inverse into A is equal to E inverse law, it can be written as E into X is equal to A inverse into B. So therefore, according to the identity law, E into X is nothing but X is equal to A inverse into B. So here X is equal to A inverse B is the solution for Ax is equal to B. For the equation Ax is equal to B, X is equal to A inverse B is the solution. See here what I have taken. So I have multiplied A inverse from the LHS side. And next one, so according to the associative law, it can be written as A inverse into A is equal to X and this is A inverse into B. So according to inverse property, that is A inverse is equal to identity element. According to the identity law, we have E into X is equal to X and therefore we say that X is equal to A inverse B is the solution. Is the solution for this is Ax is equal to B. For Ax is equal to B, A inverse B is the solution. Clear? And now we have to show that it is unique. So here there is a property that it has a unique solution. So how to prove it's a unique solution? And now we have to take two solutions and we have to claim that those two are equal. So suppose uniqueness. So this is, I am checking the uniqueness. For uniqueness, suppose there exist x1 and x2 are two solutions. See here, there are two solutions. So if I take two solutions for the single equation Ax is equal to B, so here if x1 is a solution, it should satisfy the equation that is Ax1 is equal to B. If x2 is a solution, it should satisfy the same equation. So this is 1 and this is 2. From 1 and 2, see here from 1 and 2. So both are the b values. So I'm equating, that is ax1 is equal to ax2 according to the left cancellation law. So a is cancelled and x1 is equal to x2. See here, I've taken two different solutions and I've proved that both are same, and therefore we say that ax is equal to, so ax is equal to b have an unique solution. So which solution it is? Unique. So this is how we have to show uniqueness. We have to take two different solutions and we have to equate these two, and x1 is equal to x2, both are same, and we say that it has an unique solution. Therefore we say that ax is equal to b have an unique solution. And the next equation here is given as ya is equal to b. And now I am going to consider, see here, consider the second equation. This is ya is equal to b. And as you all know that, what you all know, G is a group. So for G is a group, since G dot is a group, and it is also given that a comma b, so a comma b belongs to, so a comma b belongs to G. See here, a inverse comma b belongs to G, and according to the closure property, a inverse comma b belongs to G, a inverse into b belongs to G. So keep it aside, and now we have to find the solution for ya is equal to b. For ya is equal to b, consider now y into a. Y into a is equal to b. For this solution, we need the value of a here. And now I am going to multiply both sides with a inverse. So if I multiply with a inverse, what happens? That is ya into, see here, I want to cancel this a here. This is a inverse, and this value is also b into a inverse. So now y into a inverse is equal to, see here, this can be written as a inverse into b, and therefore a inverse value is equal to e, which is equal to a inverse b. So y value is equal to a inverse into b. See here, a inverse into b, this belongs to again G, and therefore y is equal to a inverse b is a solution for, it is the solution for the equation. So which equation it is? Ya is equal to, so for ya is equal to b, ya is equal to b, y is equal to a inverse b is the solution for, this is ya is equal to b. So here we got a solution, that is y is equal to a inverse b is a solution of ya is equal to b. And now we have to check for uniqueness. So for uniqueness, the process here is we have to take two different solutions. So let y1 and y2. So let y1 and y2 be two different solutions, two different solutions for the equation ya is equal to b. Now if they are different solutions, see here, it should satisfy the equation. If y1 is a solution, therefore this is y1a is equal to b. And next, if y2 is a solution, it should satisfy the equation, that is y2 into a is equal to b. So this is 3 and 4. See here, from 3 and 4. So from 3 and 4, both are b values, and I'm equating, that is y1a is equal to, this is y2a. Now by the right cancellation law, according to right cancellation law, y1 is equal to y2. Now I have taken different solution y1 and y2, and I have shown that those two are same. So those two are same, and now we can conclude that ya is equal to b have an unique solution. See here, which solution it is? Unique. So finally we agree that it has a unique solution. See, so ya is equal to b have, which solution it is? Unique solution. See, first thing here is what is given in a group G, a comma b belongs to G. The equations ax is equal to b and ya is equal to b have unique solutions in G. And now see here in the proof, what is given? G dot is a group and a comma b belongs to G. So G has four properties. One is closure, associativity, identity, and inverse. Now I am using the inverse property. If A belongs to G, A inverse also belongs to G, such that A into A inverse is equal to E is equal to A inverse into A. Now consider the first equation, that is AX is equal to B. So after multiplying both sides with A inverse, so this is A inverse into A is equal to into x is equal to a inverse into b, and we got x is equal to a inverse b as a solution. And now we have to check for uniqueness. In order to check the uniqueness, so we have to take two solutions, that is x1 and x2 are the two solutions for the equation ax is equal to b. Now both the solution should satisfy the equation, and therefore after equating and using the left cancellation law, x1 is equal to x2, and we say that ax is equal to b has an unique solution. And the next second question here is ya is equal to b. So here ya is equal to b, as you know that G dot is a group and a comma b belongs to G, and a inverse b also belongs to G, and according to the closure law a inverse into b belongs to G. And if I consider this equation ya is equal to b, so if I multiply a inverse on both sides, and here a inverse is nothing but the identity element, and y is equal to a inverse into b, it is the solution. Therefore y value is equal to a inverse b is the solution for the equation ya is equal to b. And now we have to check for the uniqueness. So in order to check the uniqueness, we have to take two different solutions, and we have to show finally those are same. So y1 and y2 be the two different solutions for the equation ya is equal to b, and if y1 is a solution, it should satisfy the equation, and y2 is a solution, it should satisfy the equation. So b both sides equal, and therefore y1a is equal to y2a. After right cancellation law, y1 is equal to y2, and therefore ya is equal to b have a unique solution. See, finally we conclude that in a group G, for a comma b belongs to G, the equations ax is equal to b and ya is equal to b have unique solutions in G. So this is the most important theorem, repeatedly asked the theorem. So if you really like and understand, please pass it on, subscribe, and stay connected. And I'll be uploading so many videos, and go to the playlist. It will be very, very helpful for your preparation. Thank you so much for watching.